Okay. So next part is that we'll do the temperature sensor in the Tinkercad. So I'm doing one. I'm already completed one. So we'll do four first. See the result. Afterward, we'll do the one by one connection and the code in the Tinkercad. Okay. So this is what I did. So I'm going to the start simulation. So this is a temperature sensor. This is Arduino. So I'm going to the code serial marking opening. We can see that 35 degrees Celsius coming. So I'm going to the temperature sensor, click on that. I'm creating the artificial environment in the Tinkercad software. So I'm changing the thing. For example, this is the 64 degrees Celsius. So you can see that 65 degrees Celsius is coming. Okay. I'm creating the artificial environment in a Tinkercad. So for example, this environment is 30 degrees Celsius. That is measured by Tinkercad and displayed in the serial monitor. Okay. This step will do the one by one process. So for that, I'm going to home position in the Tinkercad. So plus icon, circuit. It is open in new. So I'm changing the name. For example, name. So here I'm doing the I'm one Arduino, one breadboard. Okay. Next, temperature sensor. So where is the temperature sensor? TMT, TMT 36. Okay. Just I'm dragging to breadboard. I'm placing here. For example, placing here. We can see that have a three pins. We know already. One first one, two pins are the ground and VCC. Another pin is the data output pin. Okay. So this is ground and this is voltage and this is power. So and ground is connected to ground. So for example, this is a ground and this is a power supply I'm connecting here. Okay. So next this is a black color. I'm changing the color. I'm changing the color into black and this is convert into red. Okay. This red color. So this is positive. Just I'm going click there and click here to here 5 volts. Okay. Change the position. Next we'll go to the black color. So negative. So from here. Okay. So next select the line. Select the line and drawing to same positions. Positive. Okay. So I give the power supply and the next power supply to the temperature sensor, which means I'm connecting positive and negative to the temperature sensor and other so data pin. So I'm connected here, data pin I'm tagging. I'm taking into data pin. So just minimize it. Here maximize it. Okay. So data pin change the color into, for example, purple. So connections are perfect. Next we need to write the code. So we go for the code. After successfully connection, I'm going to the code. So this is the code. We'll explain one by one step process. Okay, first temperature pin is connected to A0. You can see that. Wait a minute. I'm going to code first. So temperature sensor is connected to A0. Okay. So we know that temperature sensor is connected to A0. Okay, it's connected to A0. So I'm the A0 is defined as so constant in it is integer. Temperature pin is a temp pin is a integer that is equal to A0. So temp pin means the indirectly we will call it A0. Okay. So next void setup from here to here void setup. So void setup CL begin 9600. So we'll begin the CL monitor. We'll start the initialize the CL monitor. Okay. From here to here is while loop. From here to here is while loop. So what is the loop function? We know that it is the logic. So what is the float temperature? Float temperature equals to, so we read the first what to do, we connect the A0 temperature sensor connected to A0. So this is a temperature sensor, for example, connected to A0. So unlock read of temp pin. We already know temp pin equal to A0. So we read from the unlock read temp pin. So we store it online read and we do the some calculations from year to year. We doing the some minus 20 after reading minus 20 voltage. After that we do the some calculations from year to year. We are doing some calculations into 3.04. We are doing the calculations. After that we are doing the map this value into 0 to 1023, 0 to 1023 minus 42 plus 25. Okay, these all things is stored in the temperature float. So float in temperature. The temperature is called float. For example, this temperature is float. We store the data in the temperature. Okay. Then temperature equals to float data. For example, 14.05, 20.05 like that. The data will be stored in the temperature sensor. Okay. After that, so serial print temperature. So in the serial monitor, first print the serial temperature colon. So what is space? In the space what you are printing? Temperature. Temperature means this data, float data. For example, 14.05. This is a float data. After that serial print and C Celsius. Okay. So after delay, after this wait 500 microseconds. Okay. After I can repeat the these functions, this logics. Okay. We'll execute the program and we'll see the output. I'm clear all data. So start simulation. You can see that just I'm adjusting to temperature sensor. Okay. Just I'm increasing temperature sensor here. Okay. So we can click in the Tinkercad software. So we'll create the artificial environment to the temperature sensor. Just I'm dragging. You can see the, for example, 50 degrees Celsius. There is the artificial temperature. In the artificial environment, the temperature is 56 degrees Celsius. That is measured by temperature sensors and printed in the CL monitor of the system. Okay. So plus or minus 0.5 is there. Okay. For example, we go to 68. It's showing 68 perfectly. Just I'm adjusting 66. Okay. 53, 54, something like that. You can see that. So we're changing the temperatures up to, just minimize it, up to, we get what is the maximum temperature minus 125. What is the minimum temperature is that minus 40. Okay. So after this, I'm simulate this one. So for example, below 30 degrees Celsius is there. Room, what is the room temperature? Around 30 degrees Celsius is there. For example, below 36 degrees, we need to turn on the LED, green LED. From the 30, from room temperature to, for example, 70 degrees Celsius, 60 degrees Celsius. So we need to turn on the LED, green, yellow color LED. After more than the 68 degrees Celsius or 70 degrees Celsius, we need to turn on the red color LED. So this experiment we'll see in the Tinkercad. Okay, we'll detail in detail in explain. Okay, we already discussed. So the color connections are already done. So we'll do the again. We'll one by one connections. So I'm starting simulation. So start the simulation. So start simulation is done. So simulation is started. We can see the temperature is. So for example, we can see that the temperature. I maximize it first here. Okay. Just I'm moving this side. Wait a minute. Okay. On. Okay. So we can see that the temperature is. So up we get here you can observe green color LEDs turn on. Okay. Up to we'll see that. So for example, this is a 30. So up to 20, 29, 28 degrees Celsius, the green color is turn on. So after that, we can observe the green color LED is off and the yellow color LED is turn on. To we can see that to up to 70 degrees Celsius, 69 degrees Celsius, around 69 degrees Celsius. Wait a minute. What happened? Okay, you can see that. So 55. So 49 to 50 degrees Celsius, the yellow color LEDs turn on. After that, behind this, so the red color LED turn on. Okay. So we'll do the connections and after that we'll write the code. Step by step process. So I'm coming to the home position of the Tinkercad. I'm click on the place icon create. So click on the circuits. Okay. So after that, what we need? So three LEDs, three resistors, one temperature sensor, one breadboard, and one Arduino board. Okay. So we'll place the one by one. So I'm placing the Arduino board. After that breadboard. Okay. So next temperature sensor. Temperature sensor. I'm drawing the temperature sensor. Next. So we need three LEDs. I'm placing here one LED, two LEDs, and third LED. So I'm changing the colors. So first we need this color is green and this one is a red. Sorry, this one is yellow and this one is a red. Okay. So next we take the resistors. One, two, and three. Okay. So after that I'm connected to positive of the LED to resistor. So I'm going to this is the positive. Anode is the positive and cathode is a negative. So I'm connecting the anode of the LED to the one side of the resistor. This one and this is second and this is the third LED I'm connecting. Done. So again, so next this one is the so cathode is connected to ground. So I'm connecting here ground and here and here. Okay. So this is a negative. So we ground. So we need to change the color into black. So I'm changing the color into black. I'm changing the color into black. Okay. So next, so this is a one LED is connected. Just I'm moving towards the pin set. Which so just move upside. Just move this side. Okay. So this is connected to pin number 12. This red color is connected to pin number 12 and this connected to 9. Green yellow color LED connected to pin number 9 and green color is connected to pin number 7. So its connection is done. I'm changing the color. This is green. So I'm changing the green color. Okay. And this is also yellow color. And this one is red color. Okay. So next this is the ground. So I'm connected the ground to the ground of the Arduino. Okay. So this is a ground and this is a positive. Positive is connected to, so 5 volts. Just state. Okay, this is positive and this is black. This is ground. So I'm going to change the color into black. Next. So we need to give the connection to the temperature sensor. We need to give the connections to the temperature sensor. And this one is the ground. So ground is connected to ground. Okay, this one is the power. Power pin is connected to power. Okay, this is red color. Next, this is a out pin. Out pin is connected the output is connected to the A naught of the Arduino, A0 of the Arduino. Okay, I'm changing this color into some purple. Okay, connections are done. So next we'll write the code. So for that one, I'm going to code. Click on the blocks. Go to the text. Continue. So here, so default blinking of LED program is there. Default blinking of LED program is there. I'm changing into the max large. Okay, just undo and delete. So first we need to define the pins. Okay, so for example, green color, int green LED, int green LED, green LED equals to, what is the pin number? 7. Next, int yellow LED is connected to pin number 9. Next, int red LED, so it's connected to pin number, so red LED is connected to pin number 12, so pin number 12. Next, int temp, constant in constant, after this constant int temp equal to A0. So we define the 4 pins. Okay, so small correction, this is the constant LED, so this is also constant, so this is also const int, and this is also constant, this is also constant. Okay, after that we need to define void setup. After this void setup, void setup, so bracket close and door brackets open. So what is that? Pin mode. So green LED, I'm copying green LED here to here. So green LED comma capitals of output. Next, pin mode, pin so pin mode, brackets open. Next, yellow LED, I'm copying the yellow LED to here. Yellow LED comma output. Okay, next again pin mode, green LED. I'm copying the green LED. I'm copying green LED to here and output. After this, I'm we need to, after this what to do? So I'm going to close the brackets. So 3 LEDs are defined here, and setup mode also defined successfully. So we need to see the temperature in the serial monitor. For that we need to begin the serial monitor. We need to initialize the serial monitor here. Okay. So for that one, so I'm write the code serial dot begin brackets open, 9600, bracket close. So this is the void setup. Next, after that, we need to write the while loop. So while loop, brackets open and brackets close. Okay. So while loop, first we need to measure the temperature. So float temperature Tm. So temperature equals to map of 1. So map of 1, 2, 3. So what to do? Analog read of analog read. So float temperature equals to map of analog read of A0. Otherwise, we write here temperature. Temperature means indirectly we write the A0. A0 minus 20 into 3.0 and mapping 0 1023 to minus 42 plus 25. After that, serial print temperature. So after next, so I'm copying the serial print, paste here, next paste here, and write the temperature only. So on brackets in the between temperature. Next, so next is that again I'm not doing now temperature. I'm copying the serial monitor code line, paste here in between degree Celsius. So I'm writing the space capital C. Okay. So after this code is correct or not, we'll check. So for that, start simulation. So serial begin void setup. Serial was not declared in the scope. So what is the mistake here? So it's showing the mistake here. So serial dot. We can see that. So serial was not declared in the scope, which means so serial this serial is not declared in the above. So what is the mistake here? Here capital S is the serial. So we write the small s. I'm going to here capital S. Just refresh the page once. So go to the code. It is capital S. What happened? Capital S. Wait a minute, some problem is there. So I'm writing the capital S. So capital S begins serial monitor. Start simulation. Yeah, we'll see the serial monitor. So temperature 25 degrees Celsius continuously coming. So we need to create in the this coming not continuous. So come in the new line. So for that I'm going to the code. In the last line serial print dot here Celsius is there no. In that write the ln ln ln. Okay. See the start simulation. First clear the output. You can see the 25 degrees Celsius, 25 degrees Celsius. It is continuously coming. So we need to further we need to write this some delay. So I'm delay. I'm going to delay of delay of 500 microseconds. Okay. Smart simulation. So first clear the data temperature. You can see that some delay is there. Okay. So till now program was correct. So after this, what to do? So we need to with help of temperature, we need to turn on the green LED or yellow LED or red LED with respect to the temperatures. So first we'll discuss about it first band range. So first, so 0 to 30 degrees Celsius or 32 degrees Celsius. The room temperature is 30 degrees Celsius. So from here to here is so green color LED must on. Okay, after this, so yellow from 30 degrees Celsius to, for example, what is the highest temperature in summer? The summer is that 50 degrees Celsius. So this is the 50 degrees Celsius. The yellow color LED must be turned on. So after this, so from above 50 to So 125 degrees Celsius. The red color LED must turn on. Okay. So we know the temperatures. So after that we need to write the logics. Okay. So I'm going for the this one. So I'm write the first if condition. If so I'm write the if condition. So we are I'm writing here I'm writing the if condition. For example, if brackets open close in between the brackets. So temperature copy the temperature and paste and is greater than 30 degrees. Okay. So in for that if the logic is correct execute these lines. What is that? Execute lines. So digital right. So which line? Green color LED. Green color LED, comma, high. So we'll check the start simulation. It is on or off. No, it is not on. Wait, what happened? The temperature green LED. Okay. So I'm start simulation. Change the temperature. Okay. So it's turn on. After that, so green color LED only we need to turn on. So for that, so remaining LEDs must be turned off. So for that, I'm writing code digital right. So yellow LED, comma, low, semicolon, enter. Next other digital right, green LED. Okay, comma, low. Okay. So after the what is the logic? If what is the logic? Next from 30 to 50 degrees Celsius. So 30 degrees Celsius greater than temperature and less than the 50 degrees Celsius. Correct? Okay. So for that I'm brackets open, brackets close. So here. Next, I'm calling the digital right. Digital right. Here we need to turn off the green LED. So green LED I'm copying here, paste here green LED, comma, low. Next one is digital right. Digital right, green color, comma, yellow LED, comma, high. So digital right, comma, green LED, low. Sorry, this is green LED low. This is a red color LED. Here also mistake. Copy here. This is red LED and this is red LED and this is also red LED, comma, low. Okay. Next after that this logic if the temperature no not red LED not copy copy paste here. So this is also paste here greater than 50 degrees Celsius. 50 degrees Celsius. No logic. Okay. So I'm going to here. I'm copy the three lines. I'm copy the three lines. So what to do? Copy. This must be low. This must be high. Okay. So we need to start the simulation. Something went wrong. Small correction. This is not less than 30 degrees Celsius. Smart simulation. This is the less than. Okay. So this is greater than 50 degrees Celsius. We'll see that first. Okay. Release on 51 degrees Celsius. So for that also, this is come here 50 degrees Celsius and this is 30 degrees Celsius. We'll check working or not. This condition is perfect, but middle condition we'll check it once. So these are some changes in the code. So else if sorry first the LED is checking this condition, it is true, again check the this condition, else if this condition checking, if this condition also is wrong, check the another program this condition. Okay, so we'll see that. So for that I'm just moving this side. Start simulation. So something before taken is missing. Wait, before expecting before taken. But there's a mistake. In the small correction also, for the else there is no condition. So there is no condition. So that I'm removing this one. Again smart simulation. Start simulation. Yeah, it is working. So it is below 25 degrees coming. Just is maximize it. I'm moving this side. Maximize it. I'm moving this side. Wait. The temperature we can see. Yeah. Okay. So successfully completed. You can see the code. So I'm removing those things. First removing those things. Perfect. Okay. Smart simulation. Stop simulation. In Tinkercad, we'll see the DC motor connections. Okay. First we'll see the start simulation. It is rotating one side. It's 5 seconds. After 5 seconds, it's rotating opposite side. Okay. We'll do one step connections and write the code. So for that, go to home position. New. Click on circuit plus circuits. So what we needed? What first one is the Arduino board. Okay. Anode battery, DC motor, and L239 L239D circuit. Okay. Okay. Next we'll connect it one by one. So first Arduino ground. I'm taking the ground to ground. Where it is ground? Okay, ground. Okay. Ground is connected to ground. Next ground, again ground is connected to negative of the battery. Next enable pin is connected to pin number 5 volts. So I'm connecting 5 volts. Same pin is connected to power input. Next input pin. Input pin is connected to pin number 3. Next output pin is connected to DC motor, and output 2 is connected again Just a minute. Click on escape. Just delete this line and connected this one to this line. Just adjusting into square. Next, output 2 is connected to terminal 1 of the DC motor. Input 2. So I'm going to pin number 2. Okay. Next, power 2. Power 2 is connected to positive of the 9 volts. I'm changing the colors first one by one. So this is red, and this is a black, and this is a black, and this is black again. This one is red. This one is red. Next, this is the ground, and this one also black. Why? Because it is a ground, and is connected to some green. Again, green is there. I'm connected to blue, and this is connected to pink, and this is red color. Why? Because it is a 5 volts red color. Okay. So connections are perfectly done. We go to the code, click on blocks, text, continue. So we have a pin setup, pin mode, capital P, pin mode, 2 comma, output. Next, pin mode, 3 comma, output, 3 comma, output. Okay. Next, go to the loop, digital write, 2 comma, high, and 3 comma, low. Digital write, right, brackets open, 3 comma, low, 3 comma, low. Okay. Next, delay of 5 seconds. I am removing delay of 5 seconds. Here, delay of 5 seconds. Next, same digital write 13 comma. Next, 2 comma. I am deleting this one. 2 comma. Wait a minute. 2 comma, low, and the next 3 comma, high. Digital write 3 comma, high. Delay of 5 seconds. Okay. We'll run the code. First, click on start simulation. What is error? What is error? Expected end of the input. So that we go to the code. What is error? So here loop open, but the while loop is open here, but we not close anywhere. So we need to close while loop. For that, close the brackets. Start simulation. You can see observe. You can see that it is 5 minutes. You can see time. Just simulate. Carefully watch. Your time also there. 1 second, 2 seconds, 3, 4, 5, and after that is rotating opposite side with the 5 seconds. Okay, 5 seconds, 5 seconds. You can stop simulation. So we want to edit the code, go to code. So I'm changing here 3 seconds one side and 5 seconds opposite side. Just click on start simulation. You can carefully watch here. It is rotating 5 seconds one side and 2 seconds opposite side. Okay, with RPM of 16530. Okay. Okay. This is the one motor is completed. So we'll add the two motors. We already discussed L2 390 driver capacitor and in the two motors, two DC motors. So one side is connected to with the DC motor, we are connected against side DC motor. Okay, for that we need to take the extra DC motor. Okay, DC motor. So I'm taking is same connections, just two connections are increasing. So this is input 3, so is input 4, so that is pin number, so input 4, pin number, I'm connecting 5. Okay, pin number 5. Next, not this, input 3 is connected to pin number 3. Okay, just I'm rotating this, first I'm read this one. So next, go to the components, DC motor, I'm placing here. Okay, next, output 3, output 4, output 4 is connected to negative, and ground is connected to ground. Ground is connected to ground. Okay, just I'm read this one. We'll take extra ground. So I'm going to ground, just ground, and connected the ground. Okay, all right, I'll convert into black color first. This one. So this is also black color. Okay, this color changes to for example bronze, and this color is connected to gray. Okay, so two pins are connected. Enable 3 connected to, this is same no, connected power 2, and this is output 3 connected to, so this is red color. Why? Because it's positive, and this one also red color. Something, this one is black. Which one? What is the pin number? It is this one. What is the pin? Ground, and this is a ground. Ground. So I'm shorting this ground. No, just connected to ground. Okay, we'll see what will happen mistakes. So connections are done. So just go to the code. Some are adding extra 3. So just pin mode 4 comma output, and pin mode 5 comma output. So first, before that I'm just on this one. Okay. And while loop, coming to here. So first we rotate this one. After that we rotate after motor. So it's motor number 2, digital right 4 comma low, digital right 5 comma high. Okay, these are caps. Okay, next delay of 5 seconds. Next, to go to reverse, digital right, went wrong, digital right 4 comma high, digital right 5 comma low, delay of 2 seconds. Okay, we'll start the simulation first. That is rotating 1 2 3 opposite side. You can see it is also rotating. We are not turn off this one. So after this is continuously wrong. So what is our mistake? After that we need to stop the DC motor. Okay. So for after this we need to stop the DC motor. Which one? So this one. So digital right, high 3 comma low, 3 comma high must be after the 5 delay of 5 seconds. The pin number 3 must be low. Okay, we'll write the code. Digital right 3 comma low. Okay, we'll see. Start simulation. It is power on. Yeah, perfect. After this is rotating. Okay, but this continuously is also rotating. So what to do? So we need to stop after this. After 2 seconds we need to stop the pin number 4 must be low. So we need to stop the second DC motor so that the pin number digital right 4 comma low. We'll see. Okay, perfect. One DC motor is rotating, another DC motor also rotating. Yeah, perfect. One more DC motor rotating one direction. After that, some delay. After that is rotating opposite in the direction. After the first motor is off, then second motor is rotating one side. Some delay of time. After that is rotating opposite side. After it is off. Yeah, it is perfect. Okay. Yeah. These are PIR sensors connected to Arduino. First we'll see the output. Then we'll practice one by one. Connect one by one pins. Okay. I'm going to a code. Open serial monitor. Can you see? No motion is detected. Just click on this. Just rotate it. Wait a minute. Okay. Okay. First we'll see the output. After that we'll connect one by one components to the Arduino. Okay. So this is a code. I'm start simulation in a Tinkercad. Start simulation. So I'm just rotating the object. You can see motion is detected. After that motion detected, no motion. Right now no motion. Just move come to the object is a human or animal coming into in the range of the PIR sensor. Motion detected after few seconds. No motion. Come motion detected. Motion detected. No motion detected. Right now no motion. So you can see motion detected. No motion. Okay. This is the output. We'll see. One by motion we'll connect the PIR sensor to the Arduino, and after that we'll code it, write the code, and we'll see the start simulation. Okay. So for that I'm going to home position, place icon, circuits. It is open. So what we need first ring Arduino. Just I'm placing here Arduino here, and PIR sensor. PIR sensor, you can see PIR sensor. Okay. So we can see. So this is a signal pin. So signal pin is connected to pin number 12, and this is power. Power pin is connected to the 5 volts, and this one is a ground. Ground is connected to the ground. Okay. I'm changing the colors. So this is a black, and this one is a red, and this one is a some other color blue. Okay. So these are connections are done. We'll write the code. So start simulation without writing a code. First we'll go to the code. So go to the click and blocks, text, continue. So default program is there. I'm deleting the default program. Okay. So we'll write the code here. We can see I'm defining two pins. Can go to the pen. I'm select the pen. Wait a minute. Okay. Pin number 2. So PR sensor pin number 2. I'm connecting signal pin. It is signal pin. No. Signal pin is connected to 12. Okay. Next LED 13. We know that this is LED is connected to the pin number 13. Okay. You can see next wire setup. This is a wire from here to here is a wire setup. Pin mode, PR sensor, which means already 12. We know that 12. This is a 12 input. Next LED pin. LED pin which means 13. Pin number 13. So it is the output. Okay. So next I'm beginning the serial port. Serial begin 19,100. Next serial port what I'm printing? Just let's loading. Okay. After while setup, I'm writing the while loop, the logic of the program from here to here. So first, I'm read the pin. So first int motion detected. So equal to digital read pin PR pin, which means PR pin we know that 12. So from pin number 12, we read the data. We read the data stored in motion detected integer. Okay, which means integer means motion detector is a integer. So I'm storing the data, which means value stored in motion detector. Okay, next time write the logic. If motion detector equal to high, this is one. We read the from rear sensor zeros or one. Okay, so zeros are one always stored in the motion detector. Okay, from the motion detector we are coming to high. We know that high means one. So motion detected, which means 1 equal to 1. So the logic is correct. So then digital at LED high and also in the serial printer and motion detected. Okay, you can see comment here. These are comments. I'm writing the motion is detected. Okay, then LED turn on. Next after that I'm writing the serial printer line. So in the serial mode I'm writing motion detected. Next if the logic is wrong, so if it is 0 and is 1, so it is not equal to 0. So which means the logic is wrong, else digital at LED pin number means 13. So low. So LED turn off and I'm writing in the serial monitor no motion detected. Okay. So I'm giving the from the delay from the after that delay of 1000 sorry delay of 100 seconds, delay of 100 microseconds. So after that is motion continuously run. So checking the data, check after that compare with the condition. So it is true, perfect. It is false, execute the statements and delay of the 100 microsecond again is continuously run. Okay. So I'm adding this total things. Okay. This is the code. After that I'm going to start simulation. Start simulation. So it is working. Go to the serial monitor, more motion detected. First we can see from first. So motion initializes. So no motion detected. I'm going to PR sensor. Just scroll down below. Okay. Click on below. We have some. Just minimize it. Okay. Okay. Scroll on here. This is a range of the from here to here. From here to here. This is a range. Okay. This is a range of the PR sensor. Okay. So I'm just moving to some object. So we can I'm moving. So motion detected. Motion detected. Motion detected. But there is no after that no there is no motion. So we can see after that is no motion. We can see here also no motion detected. This is the range. I'm coming to inside of the range. So the sensor detected motion. Again motion detected. Motion detected. Motion detected. The object is moving out of the range of the sensor, no motion detected. The object or animal or human coming into the range, then the sensor detected motion. So in the serial monitor, motion detected. And also you can see LED. In the LED, just I'm coming down, scroll down to below. You can see the motion is detected. The motion is detected. You can see here LED is blinking. LED is on. We can see here. I'm just, you can see motion is on. Okay, motion is on. So I'm doing star simulation. So we are coming to the Tinkercad home page. So this is our example. So we'll tinker this first. Then we'll see the connections one by one and also write the code. Okay, first I'm simulating the this code, start simulation. Yeah. Coming to the serial monitor. Okay. Coming to serial monitor, we can see we can adjust the data. 422, the 476, the Wi-Fi not 7. So just observe that 464 means it is turning on. So which means this is a dark. Coming towards the light, the LEDs of the light intensity also increasing. So depends upon the light increasing, the LED is turning off. So depends upon our logic for how much light intensity we need to turn on the LED or turn off the LED. That is our depends upon our logic. Okay. So towards the dark, towards the night, it is increasing. Okay. So this is the circuit diagram. So we'll connect one by one connections in another new experiment. So for that I'm going to home position. So for that home position, wait a minute. This is different purpose. Just I'm first simulating this one. So we'll go to the home position. So for that, click on home. So we'll go to the home position. Click on the create sketch circuit. Okay. So this is our reference. So the LED the LDR consists of two pins. One is connected to 5 volts and another is connected to ground via resistor, and the second terminal also connected to direct pin number A0. Okay, same thing will connect. So first I'm drawing to Arduino. Next I will drag into breadboard. Okay, next LDR. We need another resistor. So resistor in vertical, I'm changing the direction into horizontal. Okay. So this is connected to ground. So this is ground. And this is connected to positive. Okay. So this is converted into black color and this is converted into red color. Okay. So this red is connected to 5 volts of Arduino. So via cable. Okay. Next, this is the ground is connected to ground of the Arduino. Just I'm connecting. Okay. This one is a black. Next. So we need LED. I'm placing here LED. So LED of resistors. So I'm changing to ohms, 500, 200 ohms. Okay. This is negative. We know that this is cathode is negative. It's connected to ground, and this is connected to pin number 10. Okay. So pin number 10. So I'm changing into purple color. So this is the connections as per that. So pin number 10, I know is correct. So pin number, go to the code. After that, I'm going to the code blocks. It is text and continue. So this is a default program of blinking of LED. I'm erasing totally code. So we need to write the fresh code. Okay. So I'm paste the code step by step. First I'm paste the 3 lines of code. I will explain. So first one is the LDR pin. It's connected to A0. Next light pin is connected to 10. Next threshold equals to the 500. Okay. So this is the 3 steps we are defining. After that we need to go for the wide setup. So this is a wide setup code from here to here wide setup. First one pin mode light pin output. So we am define the pin light pin. Light pin means 10. So 10 is the output. Next I'm begin the serial begin. So serial monitor was initializing here. Organized with the bond rate of 9600. Okay. So after that I'm write the while loop code. So I'll explain the first while loop. I'm taking another kind of pen. So from here to here is while loop. So first in light intensity equals to unlock rate of LDR pin. So LDR means A0. So A0 pin is connected to LDR. So it is unlock read. So we are reading the data from the A0 pin. So that is stored in integer of light intensity. Okay. Next we are serial begin print light intensity. Next we will print the light intensity what we are measured from the unlock read of pin A0. Okay. Next time we are writing the some logic. So for example, some threshold value. For some threshold value, we need to turn on the LED. For other threshold value, we need to turn off the LED. So for that, I'm writing the logic. If the light intensity is greater than threshold or less than the threshold. What is the threshold value? 500. So here is the threshold value is 500. So light intensity means so we are measuring we are taking the data from the A not pin. So that is stored in the light intensity. So we are comparing the light intensity with 500. If the logic is correct, execute the two statements. What are the two statements? So digital right, light pin high. So which means light pin means 10. 10 is connected to LED. So LED pin high. And also serial pin street light on. So these two statements will be executed when the logic is correct. If the logic is correct, wrong. If the logic is not executed, if the logic is not satisfy the condition, so then what will happen? Else. Coming to the else loop. What is the else loop? We write the lines, declarations. So we are writing first declaration as digital right, digital light pin low. So light pin means A0. So light pin means A0 and the low. So it means off. And also serial println and street light was off. Okay, next after coming of this, we wait delay of 500. So after that, it is executed repeating the logic. Okay, we'll see execute. First, I'm removing this content. So I'm going to start simulation. Smart simulation. Okay, what is the data? We'll see in the signal monitor. The data is 760 to 249. Okay, just I'm going to here. I'm changing it. What is the data? 31416, 328. Okay. So actually we did one mistake. The LDR pin is not connected to A0. Okay, we connect the LDR pin to A0. Okay. So we'll next go to the code and start simulation. So first I'm creating the data. Okay. Can go to it. Just assume it. What is the value of 568? Is off. Just I'm moving this side towards the dark side. It is 517. It is also off. Wait. Just wait. Okay, 452. So threshold value below the threshold value. What is the threshold value? We know 500. So 452 means the logic is correct. Then it executes the two statements. So what is the statement? Digital right, light pin comma high, and serial println street light on. So this is on and is correct street light. In the serial println, we know that serial light street light is on. Okay. So that correct. I'm stop simulation. If I check, I'm going to towards the light. I'm dead end come to the over of the light. What is intensity? 467, 417. 417 means the more than the threshold value, which means the logic is wrong. So it executes the light pin low. So which means the LED off and then the serial monitor also the street light was off. This printing. Okay, I'm start simulation.